Hello. Today we're going to talk about how to draw the three principal rays coming from a light source. In this particular case, our light source is going to be this arrow. It's just a way of representing the direction, the orientation of the object, and its size. So we know that this object is going to give out light rays in all directions. However, if we were to try to draw a representation of all of these, it would be impossible due to the fact that there are infinite number of rays going out in infinite number of directions. So we're going to focus simply on the three principal rays, 1, 2, and 3. The first one being the one that goes in parallel and out through the focal point. The second one being the one that goes through the center of the lens. And finally, the opposite to the first, in through the focal point, out parallel. So those are the three that we'll be able to use in hoping to form our image on the opposite side of the lens. The first one that we're going to look at is the in parallel out through the focal point. We have a light ray that comes out parallel to the axis of the lens, hits the lens, and now is going to turn and extend out through the focal point on the opposite side of the lens. Because it's a convex lens, it has all lenses have focal points on either side, so this is where our lens is going to be, where our focal point is going to be, and our light ray is going to come in parallel out through the focal point to here. We're going to look at what happens within the lens in just a moment. It does not, this is a model of what's happening, it's not a direct, it's not what happens in reality. Our second line is going to be the one that goes through the center. So we're going to look at from the tip of the object through the center of the lens and extend onwards. Again, not reality, just the model. We'll look at that in just a moment. Should end up with what looks like the dashed line. Finally, the one that is opposite of our first one, we're going to go in in through the focal point and out parallel. We'll come out here, and ideally all three of our lines will intersect. And at this point, this is where our image is formed. Our image, because we went from the top of this object, the arrowhead pointing up there, we now know that the object is, or the image is here, orientated in that direction. While this is a good model, it's not what happens in reality. Within the lens itself, if we look at actually what's going on within the lens, in our ray diagram, we're illustrating that as it turning at the primary axis of the lens, this dotted line right down through the middle. In reality, that parallel line, this first line here, is going to come in parallel. When it hits that first boundary, it's going to turn within the lens, and then as it exits the lens, it's going to turn some more. So you get two refractions, here and here. The center line, the second one here, we draw it as if it's coming in and just passes straight through the center, but in reality it's going to hit going to turn slightly, and then it's going to turn again. And it's going to have, once again, two boundaries, two places where it's going to refract. And finally, the in parallel out, in through the focus, out parallel is once again going to come in. It's going to bend slightly, bend some more, and not come out, resulting in, if they were drawn better, all of our lines, all of our rays converging at that one point. If you have any questions, please do not hesitate to ask.